So in this problem, we need to determine the equation of a parabola with focus at the point 2, 3 and the directrix is given by x minus 4y plus 3 equals to 0. We also need to determine the length of the latus rectum. Let us begin. So here, first what we'll do, we are going to consider a straight line. Now let's suppose that this line represents the directrix of the parabola with equation x minus 4y plus 3 equals to 0. Now what we'll do, we're going to consider another line which is perpendicular to the directrix line. Now this line is chosen in a very special way. This line is chosen in such a way such that our focus having the coordinates 2, 3 lies on this line. Then by definition, this line is going to be referred to as the axis of symmetry of the parabola. Fine. Now that we have the equation of the directrix, we have the coordinates of the focus, we can easily find out the equation of the parabola. All we have to do is consider a point on the plane with the coordinates x, y. And P is going to be the locus of the parabola, and its position is very important. It is chosen in such a way such that if we join point P and point F, and if we drop a perpendicular from point P on the directrix, meeting the directrix at M, then by definition, the length of PF must be equals to the length of PM. Now we can easily find out the length PF. All we have to do is take the square root. Underneath the square root, we need to take the difference of the x coordinates of point P and F. So that's x minus 2. We square this value and then add it to the difference of the y coordinates. So that's y minus 3 squared as a result as well. Now to find out the perpendicular length PM, we have to use a formula here. Now let's say we have a point P with the coordinates x1, y1, and we have another straight line with the equation ax plus by plus c equals to 0. Then the distance of the point P, and this is going to be the perpendicular distance from the straight line, is given by ax1 plus by1 plus c divided by square root of a squared plus b squared. And since it's a distance, we have to consider the absolute value. Okay, so here let's use this formula. Then we'll take the absolute value, and we have to consider a ratio inside the absolute value. We'll begin by considering the coefficient of x of the directrix lines. That's 1. 1 gets multiplied to the x coordinate of point P. So we have 1 times x. Then we're going to consider the coefficient of y and multiply with the y coordinate of point P. But we need to add it to it. So we have negative 4 multiplied to y. And then we take the sum of the constant term of the directrix line. This will be divided by the square root of the coefficient of x and y with that we need to take, and we need to square and add them. So that means we need the sum of the squares of the coefficient of x and y. Let's further simplify. This is going to give us the square root of x minus 2 whole squared plus y minus 3 whole squared equals to x minus 4y plus 3 divided by the square root of 17, and we have the absolute value. What we'll do, we're going to square both sides. Squaring both sides gives us x minus 2 whole squared plus y minus 3 whole squared equals to x minus 4y plus 3 whole squared divided by 17. Let's further simplify. We're going to expand x minus 2 whole squared to get x squared minus 4x plus 4. Then add it to y minus 3 whole squared. So that's y squared minus 6y plus 9. That will be equals to, let's do one thing, let's cross multiply 17 with the expression on the left hand side, and then now we have x minus 4y plus 3 whole square. When we expand it, we get x squared plus 16y squared plus 9 minus 8xy minus 24y plus 6x. So here we have 17x squared minus x squared. So that's going to be 16x squared. Then we have 17y squared, and from it we are going to subtract 16y squared. So that's going to be positive y squared. Then we have 8xy minus 74x minus 78y plus 212 equals to 0. And this is the required equation of the parabola. So we've successfully obtained the equation of the parabola. Now we go to the second part where we need to obtain the length of the latus rectum. Now to find out the length of the latus rectum, all you have to do is find out first the perpendicular distance of the focus from the directrix line. So this is going to be the perpendicular distance. We're going to double that result, and that's going to give us the length of the latus rectum. Therefore, length of the latus rectum is given by 2 times the perpendicular distance of the focus from the directrix. So here we already have the equation of the directrix that came out as x minus 4y plus 3 equals to 0. X minus 4y plus 3 equals to 0. Then we had the axis of symmetry. On it lies the focus. The coordinates of the focus was 2, 3. So we have 2, 3. So we can use the formula for finding out the distance of a point from a straight line, the perpendicular distance. This is going to be equals to, so here the length of the latus rectum will be equals to 2 times the absolute value. So here what we'll do, we'll take the coefficient of x, that's 1. 1 gets multiplied to the x coordinate of the focus, so that's 2. Added to the y coefficient of y, so that's negative 4. This will be multiplied to the y coordinate of the focus, so that's 3. Then we have the constant term 3 and divided by the square root of the sum of the squares of the coefficient of x and y. So we have 1 squared plus negative 4 squared. This will be equals to 2 times the absolute value of 2 minus 12 plus 3 divided by the square root of 17. That will be equals to 2 times the absolute value. So we have 5 minus 12, so that will be negative 7 divided by square root of 17. Since we're calculating the length, we're only going to consider the positive value. So we have 2 times 7 over square root of 17, or simply put, we have 14 over square root of 17, and this is going to be the length of the latus rectum of the parabola.